Good afternoon. Uh, hope my slides are visible. Uh, Today, let us discuss another neural network model. We call it as uh, Adeline model or adaptive linear neuron model. Okay. So this is the one which we are going to discuss today. So I will discuss only this particular neural network model today. Uh, because we are going to discuss after this, as I have told earlier, uh, the one more multiple adaptive linear neural network model and backpropagation model. Let us not get confused. So today, let us discuss Adeline model. We will solve one or two problems that will that will make the concepts clear. Okay. So introduction to this adaptive linear neuron model. It was developed by Bernard Widrow and Hoff in the year 1959. Okay. Uh, yeah, Madeline, I will not tell anything about that because it is multiple, it is actually multi-layer Adeline only. Okay. So it is this Madeline is used in several adaptive filtering process to eliminate the ecosone phone lines. So this is the basic simple structure of Adeline. Normally we represent the Adeline in this way. Let me go to the model, how it is. This is how Adeline model looks like. So here, uh, as we know, these are the inputs x1, x2 to xn. These are the weights. This is the bias, and this is input is 1. So here we have y in is equal to, actually y in is equal to b plus sigma xi wi. Okay, I don't know why they have left b here. So I is equal to, I is equal to 1 to n. Depending upon the number of inputs, it is the weighted sum of this. Okay. So what happens here is, so we are having a comparator. So this comparator, or it is also called output error generator. Based on your y in and target, it gives the difference. It is called error. Okay. So t minus, based on this error, t minus y in. So the adaptive algorithm, it adjusts the weights. Okay. A new weight will be obtained. New weight will be obtained based on the error function A. Okay. So here, two important things. One is delta Wi, that is change in the error. So it is alpha into t minus y in into xi. So here alpha is the learning rate, t minus y in is the difference in this, whatever the expected, that is a target we call. Okay, this is the target, and whatever y in is there, that difference, and xi is the input. So this block, the entire block, we call it as learning supervisor. Okay, so we know that we are discussing supervised neural network models. So this block is supervised learning model because we are giving the target value and that is what is expected. Okay. Yeah, same thing. Yeah, Adeline, the learning rule, we call it as delta learning rule. Okay. Okay, it is also known as withdraw learning rule, or it is also known as LMS rule, least mean square rule. It is same. Okay, delta learning rule or withdraw learning rule or LMS, least mean square rule, everything is same. So it's based on the least mean square. Okay. So this is what I have told, that this rule adjusts the weights based on this expression alpha into t minus y in into xy. Okay. When we solve a few problems, you will come to know how these weights get updated. Okay, it's very simple and it is interesting also. Only thing is you must not go wrong in between. If one small mistake, it may give you wrong answers. Okay, so you have to be careful when you are solving these problems. Okay, if you are using MATLAB or any other simulation environment, then it will be very easy. But again, as I have told, you must know the basic idea, you must know the concept behind these models, then only it is easy to use. Okay, so this is the how we normally do using this Adeline model. Okay, you first initialize, after that, okay, assign random weights. First you initialize, assign random weights, then you are going to do the training. Okay, uh, so feed in known inputs in random sequence. Okay, so you calculate the add the new weights. 1 second, just give me 1 second. Yeah. Okay. So after that you compute the error. Okay, then adjust the weight, repeat until total error is less than this value. Okay, this is given. That means here you are going to assume what is the convergence criteria. That means you can assume the final error should be, say it is should be 1, or it should be less than 1, something like that. You can assume the convergence criteria. So you can repeat the number of epochs or iterations it will go until the error becomes, the total least mean square error becomes a certain value. Okay, of course, thinking. So simulate the network, because yeah, network will respond to any input. And last point, sometimes it does not guarantee a correct solution even for trained inputs. Okay, but whatever the examples we take here, it gives you the correct solution, but it is sometimes it may not give you a correct solution. And after you design, after you do the training, you can test this network whether it is working or not. That also we will discuss. Okay, so I'll take up a problem. Design, design, designing Adeline neural network model to implement the following function, the following function with bipolar inputs and targets, bipolar inputs and targets. Assume W1 is equal to W2 is equal to B is equal to 0.1. Learning rate alpha is equal to 0.1. Okay, these are the assumptions which you have to make. Yeah, that's all. That's all the question. Now I'll just write the truth table. X1, X2. This is 1. This is the target value. So 1, 1, 1, 1, minus 1, minus 1, 1, minus 1, minus 1. We are using bipolar inputs. So this is one only bias input, and the target is 1, 1, 1, minus 1. Okay, this is the problem given. So you may be given any truth table. You have to develop the neural network model. Okay. Okay, let me start. You have the problem with you. Okay, first step is this is the first step. Okay, I'll just write here. You need to calculate y in. Y in is equal to b plus sigma I is equal to 1 to n xi y wi. Okay, so it is initially we are asked to assume b is equal to 0.1. Okay, so b is 0.1. Okay, then x1 I is equal to 1, x1 into w1. So 1 into 0.1 plus x2 into w2, again 1 into 0.1. So this is equal to 0.3. Okay, now calculate t minus y in. So this is equal to, what is t now? Let us start for the first inputs. Okay, now here this iteration or this step is for first case x1 is equal to x1 x2 value 1 1, that is the first row. Okay, I am considering the inputs first row of the given truth table. Okay, so t minus y in, t is here in this case target is 1, so t minus y in which is equal to 1 minus 0.3, okay, is equal to 0.7. Now what I have to do is I have to update the weights. If you have any doubts, if you are not following, please ask. Okay, so now how do we update? Wi new is equal to Wi old plus, I have told you what is change in weight, that is alpha into t minus y in into xi. Okay, this is the expression. So this is alpha into t minus y in into xi. This is normally we called, it is the change in weight. Okay, this is actually wi. Okay, so now let us calculate. W1 new is equal to W1. Okay, I is 1 here. W1 old is, so W1 old is 0.1. Whatever is given, whatever we are asked to assume, 0.1. Learning rate is also 0.1. And T minus Y in, it is here. We have calculated T minus Y in, which is equal to 0.7. So this is into 0.7, and my x1 is 1. Okay, my x1 is, you can see here, x1 is 1. Right. So if you substitute, how much do you get? 0.1 plus 0.07. So this is equal to 0.17. Yes, 0.17. Similarly, calculate W2 new. Okay, so it is equal to W2 old 0.1 plus same thing 0.1 t minus y in same. Here in this case x2 is also equal to 1. X2 also equal 1. So this 0.17. Okay, so now third one is B new is equal to B old plus, here B old plus, only thing is alpha, that xi is not there, or xi is equal to 1. It is I'll just write here bi old b old plus alpha into t minus y in. Okay, so even if you take xi is 1, we know, so this will be 0.17. Okay, this we are still in the first input, first epoch, first input. Okay, so now next step what you do is you calculate the error. The error is equal to t minus y in square is equal to 0.7 square, which is equal to 0.49. Okay, so here this is the first input we have given. Okay, please let me just go back and tell you. So what you have to do is you will be given a truth table. See, any problem, we can just write the truth table for that, right? So once we, if we are able to write the truth table, we can design a neural network model. So now today we are discussing Adeline neural network model. Okay, Adeline neural network model. So what we are doing is, given a neural network model, we must know the target. What is the target? Because this is supervised learning. And we may be asked to assume the values of W1, W2, B, alpha and all. Even if we are not asked to assume, we can take random values. Okay, we can take a values like this 0.1. So after that, first part is you calculate the y in, how we used to do earlier. Calculate y in. Then second step is calculate t minus y in. Then for these corresponding values, you update the weights based on this expression. Update the weights and even the bias value also you calculate. So this is first step, first epoch, first input. Okay. Now same in, we have to go for the now second inputs. Okay, second inputs. So calculate y in, calculate t minus y in, calculate w1 new, w2 new, b and e. Please calculate. Now what is the second input in our truth table? It is 1 minus 1, right? Second input is x1 1, x2 minus 1. Now all of you calculate these values for these inputs and tell me. Okay, so I may ask anybody, just calculate and tell me what is y in, what is t minus y in, what is w1 new, what is w2 new, what is b and e. Y in is equal to b plus x1 w1 plus x2 w2. You have to take the previous updated weights here. Can any one of you tell me the value of y in?
Point 0.17, ma'am.
Very good. 0.17. So it is b is 0.17 plus 1 into 0.17 minus 1 into 0.17. It is 0.1. Right. Now, what is t minus y in? T is 1. T is 1, right? T is 1. Yeah. T minus y in. Y in is 0.17, which is equal to 0.83. Is this right?
Yes, sir.
Okay. Now calculate W1 new and W2 new. What is W1 new?
0.253, ma'am.
0.253. Very good. This is right. So it is the 0.17 plus alpha point 1 into 0.83 into 1. Very good. So what is W2 new?
0.087.
0.087. Okay, this is also right. What is B? B new? I want everyone to solve this problem. What is B new?
0.253, ma'am.
Yeah, it should be 0.253 because it is same as that of W1 new, because the learning rate 0.1 into 0.83, and of course it is 0.253. So error is equal to t minus y in whole square, which is nothing but 0.83 square, which is equal to 0.69. Okay, so what we have done here is, now we are still in first iteration only. We consider the second input. Okay, now let us go to same first iteration only. Let us go to third input. Okay, for the third input, x1 is equal to x2 is equal to, it is minus 1 and 1, minus 1 and 1. Okay, minus 1 and target is 1. Okay, so you again you calculate and tell me what is, I'll just write only now W1 new, W2 new, B new, and E. You can give these values. Let me, yeah, one of you can give. All four you can give. Yes. Can this be completed now? Can you just tell? W1 new. Anybody? Ananya? Ananya, are you there? Arushi?
Yes, ma'am.
So can you tell the values?
Ma'am, YN is 0.17.
This one you are telling, right?
Yes, ma'am. Third
Huh.
input.
Third input. How much is this?
Just, ma'am, for the third input, it is 0.08.
Which one?
For
Yeah, third. What W1 new, can you tell?
W1 new is 0.161.
161. Okay. W2 new?
0.172.
178 I have got. Okay. B new?
Ma'am, B new, I just have to calculate.
Okay, calculate Intel. Ananya, are you there?
Ma'am, is it point 345?
Which one? We knew.
We knew.
Yeah, correct. Yeah. It is point 344. Okay, it's okay. 345 you would have got. Fine. What is error? Can you please tell?
Ma'am, error is
T minus 5. What have I got?
ma'am, it is 0.92. The error would be 0.92 square, which is 0.8464.
Okay. 84. Oh, okay, fine. Yeah, next for the fourth input, the first epoch, last step. Okay, fourth input, x1 is equal to -1, x2 is equal to -1, t is target is -1. Please repeat the steps and give me the values. One of you, I will call one of you. So when I'm calling, if you are not there, I'm just making a note of it. I may need this sometimes in future. Okay, I will just when I call, if you should be there. Ananya, are you there? Agam Rai, are you there? Agam Kumar Rai, Astha Shukla, Anish, Anish Chawla.
Yes, ma'am.
Okay, can you tell me the fourth inputs? Then fourth input,
Okay. Just a minute.
just give me the values W1, W2, B and E. I think you're not able to see the screen, right? Is it visible?
Yes, ma'am, it's visible.
It's visible. Okay. So for the fourth
It's
input,
visible. I don't know if it hanged or something.
yeah, that is what I thought. 1 second, I'll reload.
Okay, okay.
Now, can you see this blank page?
No, ma'am.
No. Okay, then there is some problem. Wait. Okay. Yeah, fourth input, can you tell? I think I asked Anish, right? Anish? Anish, can you hear? No? Anupama?
Yes, ma'am.
Yes, can you tell?
Yes, ma'am.
Yeah.
W1 is 0.26213.
Wait. 0.2621. Okay. W2.
Ma'am, W2 is 2.2787.
Okay. B.
B is 0.2438.
Okay. Error is?
1.0086.
Okay. 0086. Okay. Now, what we have done is, let me just go back for this particular problem. We have considered only one epoch is over now. One iteration is completed. Okay. So we considered all the four inputs and we calculated the weights and we calculated the error. So if you just observe for this first particular iteration, whatever the values you have got, whatever the values you have got, that is 0.49, that is for the first input. For the second one we have got 0.69, and for the third input 0.84, and fourth input 1.0086. So you can just sum all these four errors. Okay. So total mean square error, total mean square error uh, is sum of all the mean square errors. Okay, mean square errors. So now you can just add these errors. It is 0.49 plus 0.69. So it is 0.49 plus 0.69 plus 0.84 plus 0.84 plus 1.0086. Okay, if you just take the summation, I think it will come for the first epoch. For the epoch 1, the total error, total mean square error is, you will get 1 second, error is, I think it is around, if you just do the addition, 3.02 I have got. Okay, please note that this is for first iteration. Now for the, like this you have to continue. Okay, so one iteration or one epoch is over. This is epoch number 1. Now the entire step, see, if you are doing simulation using any MATLAB or any other, it will be very easy. But if you are calculating manually, then it takes time. But it is okay. You will come to know how normally we do. So for second epoch, again for all the four inputs, you have to consider x1 and x2. First one, then 1 - 1 - 1 - 1 again all the steps you have to repeat. You have to calculate the e value for all the four cases. You have to update the weights, then you take the sum of the weights. Okay, like this you can continue. How long you will do, how many epochs you will see. So here what you need can do is the convergence criteria you can initially set. Say the total error should be, for example, it should be less than say 1.5, or it should be less than 1. Like that you can decide in the beginning, and you can what complete, you can, I mean, do the repeat the analysis, and you can finally calculate the weights. Now in this case what I have done is, just for your understanding I'm telling, so I'll just tell you, this is what I have done. So this is the error, total mean square error. uh, so when I have calculated this for the epoch 1, it is 3.02. All of you have got. Second one, for the second epoch, if you do it, it will be 1.938. For third one, it is 1.55. Fourth one, it is 1.4. And fifth one, it is 1.3. Okay, you can see that as we are training the neural network, the error keeps decreasing. You can see it, sixth one, if you do, it may go for 1.2 or 1.4. Say 7, it may go below 1. Okay, so as you increase the iterations, the error reduces. You can see the reduction in the error. Okay, so finally, after a few, if you set less than say 1.4 or 1 point, if you set it 1.5 is the convergence criteria error, then you can stop when 4 iterations are over. Okay, so here in this case, after 5 iterations, this is the model which I have got. This is the Adeline neural network model. I'll just write here the weights and all. So here this is b value 0.4575. Okay, so this W1 value, the final value is 0.489. 4893. The W2 final value is 0.5204. Okay, so this is the final model after 5 iterations. This is the Adeline neural network model for this particular problem. If you are implementing, this is the neural network model. Okay, this is the complete solution. This is how we do. Any doubts if you have, you can ask. I'll give one. Now, if you want, you can train. We have trained it. This is the training, how we do the training. You can check if you want. You can just calculate the value of y in, and you can see similar to our in previous classes we have discussed. You can set a threshold value and analyze whether it is less than the threshold value, the output is -1. If it is greater, output is 1. This is how you can test the network which you have designed. Okay, if it is clear, we will go ahead. I'll give one more problem, you can just try. Any doubts, anybody? Is it clear?
Yes, ma'am.
Okay, then I'll give one more problem. Just take down and use Adeline network model to train the following function. To train the following function, okay, which is given in truth table with bipolar inputs and targets. Perform 2 epochs of training. X1, X2, 1, T, 1, 1, 1, 1 minus 1, minus 1, 1, minus 1, minus 1. So this is 1, 1, 1, 1. This is minus 1, 1, minus 1, minus 1. Okay. Assume W1 is equal to W2 is equal to B is equal to 0.2. Alpha is equal to 0.2. Okay, so here this is the problem. What I want you to do is you have to train the network 42 epochs, but here in this class you can take next 5 or some 5 to 10 minutes, and you give me you perform one epoch and tell me the answers. What is the weight after one epoch? You have to tell. Okay, I may call anybody. Please, all of you, please try to do it. I know whenever I start calling the names, students they start leaving. This is not good. Okay, don't do like that. So whenever I'll call a few names, you have to give me the answer. All of you must do this problem. Okay, you can start. Can anybody tell the answers? Vishwatma?
Yes, ma'am. I'm calculating.
No, at least first input, if you have done, you tell.
First input is
Y in, can you tell?
y is 0.6, right?
Point?
6 is it right?
0.6 is right.
Okay, so
T
then
minus,
we have the error as minus 1.6,
very good, right.
and we have W1
W1
new as minus 0.6.
minus 0.6.
Did I go wrong somewhere?
Yeah, I have got minus 0.12.
Okay,
I don't know.
but
Others, anybody? W1 new, what is the answer?
Ma'am, I also got minus 0.12.
Yeah, it is minus 0.12 I have got.
oh,
Just
I might
check.
have made a mistake. I might have
Yeah,
made a mistake.
okay, okay. W2 new, anybody?
But they're all same, no? I'm W1 new,
Yeah,
W2
yeah, it
new.
will be same, correct.
Yeah.
0.12. This also 0.12. And error is 1.6 square, 2.56. Yeah, this is for the first input. Now for the second input, anybody can give the answer? Anybody completed second input?
Ma'am, for the second one,
Which one?
ma'am, the second one, y
Oh,
in is 2.56.
0.56.
No, ma'am, 2.56.
Second input. Uh, y means I have got minus 0.12.
Okay,
What
ma'am,
you
I'll
have?
check again. Ma'am,
Just
I'll
check.
check again. Yes.
Yeah. I don't know. It may be wrong also. Mine maybe, but just check and tell me.
Excuse me, ma'am.
Yeah.
For the second input, B will be 2.56, right?
Second input.
B is
Y,
2.5.
yn or E.
No, no, sorry. E for to be used to calculate Y in is 2.56, right?
For the second one.
Yes, ma'am.
Okay. Wait, 1 second. Oh, one second, 1 second. T minus Y in. Oh.
Okay. No, I'm sorry. Sorry.
Yeah, that is what.
Y in is minus 0.1.
Yeah. So whatever the threshold minus whatever Y in you have got, that has to be used. Okay.
Yes, ma'am. Yes.
Okay. Yeah.
Ma'am, it's minus 0.12 only, yn.
Okay, that's what I was a bit, even I started recalculating. It is correct, I
Sorry, ma'am.
think.
Yes,
Okay,
ma'am.
it's okay, yeah. Then t minus y in?
Ma'am, 0.88.
No, it should be 1 minus minus
Oh,
0.12.
sorry, ma'am.
It should be
Yes,
1.12, I believe.
yes, ma'am. Yes,
Right?
ma'am. Yes, ma'am.
Yes, ma'am.
Yeah.
And then W1 is 0.104.
Correct. That is correct. 0.104. W2,
Ma'am, minus 0.344.
yeah, that is also correct. B will be that value not taken down. 1 second. B value I just calculated.
Ma'am, 0.104.
0.104. Okay.
Yes.
Okay. Error is is it 1.25?
Yes, ma'am. 1.2.
Okay. 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 So similarly, you have to repeat the entire this one process for third input, fourth input. When you are done with all four inputs, so first epoch will be over. Okay. Actually, according to the problem, again for the second one, second iteration, you have to repeat. But it's okay now. At least for the understanding purpose, you just complete one and tell me. One of you please do third one and give me the answer. And finally, total error, you have to calculate what is the total mean square error. E is equal to E1 plus E2 plus E3 plus E4. Then when second epoch you do that error gets reduced. Okay. So here, this is what I have got, just 0.34. Is it right? Anybody? Y in?
Yes, ma'am.
Okay. So this is minus 0.66. So W1 new will be 0.24. W2 new will be 0.48 and E will be 0.43. Not B, this will be 0.43. Is it right what I have written, at least some of the values?
Yes, ma'am.
Oh, okay, very good. For the last input, this is what I have got, 0.21 minus 1.2 0.48 minus 0.23, and in this error I have got 1.47. Okay, so total error will be when you have added all these 2.56, 1.25, 0.43, this one, it is, I have got 5.7.
Ma'am,
Yeah,
for the third one, t minus y, won't it be 1.34?
wait,
Because
what
it's
is,
1 minus of minus, right?
no, it is -1, no, third, see.
Oh, okay.
Hmm. Okay. Is third iteration, sorry, is third input values, whatever I have written, is it right?
Yes, ma'am.
Okay. Okay. Similarly, you can do it for fourth. Okay. You can do it later. And what I want to do is finally find the total value of the error. So in this case, you will get 5.71. Okay. For this question, it is two epochs are asked, so you can complete everything. Okay. For the second time, you can repeat it. Okay. If you are interested, you repeat, because it's a mechanical procedure. uh, Finally, what happens is when you calculate the total error for the second iteration, it becomes, when I calculated, E becomes, it is 2.43. Okay, so errors reduces. First iteration error was 5.71, second 2.43. Suppose third iteration, if you are doing, see, if you are training it again, if you are training third iteration or fourth iteration, so as you increase the number of training steps, the error reduces and you will get a better model. Okay, so the finally after two iteration, the model, the Adeline network, whatever we design, it will be something like this. Okay, after two epochs, it is this, I have got 0.43, this is 0.55, this is minus 0.38, this is my output. Okay, this is the model. After two epochs, our neural network model, to implement that truth table whatever we have given, it will be something like this. Okay, this is the final answer. Now before I close today's class, I just want to tell you one more thing, a simple concept. Just if you want to test, say you are given, assume that you are given this model. Okay, you will be given truth table, whatever the truth table initially I have given here in the this problem, and this model is given. The question may be, you need to test. Okay, you need to test this whether it is right or wrong. So how will you do? So how do we test a given model whether its function given in the truth table is satisfying or not? This is called basically testing algorithm. How do we do that? Hmm. So what you do is uh, calculate y in. So you know that it is how we calculate b plus sigma weighted sum xy yi, I is equal to 1 to n. Okay, calculate this. Now, after you calculate this, apply activation function. Apply activation function. Okay, so you know that here this Adeline network uses bipolar activation function. So y is equal to 1 minus 1 if y in is greater than or equal to threshold, or it is less than threshold value. This is the condition. So in this case, if you want to verify or if you want to test, calculate y in values. Okay, you will come to know whether it is greater than threshold or equal to threshold. You will come to know. Okay, so I think in one case it will come 0.6 for the first truth table. 4 cases are there. I is equal to x1. We have 4 rows, right? So when you calculate, I just tested it. First case 0.6 it comes, second case 1.36. Okay, if you just go back here, so corresponding to this particular, the threshold values you will come to know. Above a certain value, it is positive. Below that, you will get all negative, -1, -1, -1. Okay, so just you can compare whether when you test it, what is the threshold value it is, that also can be tested. Okay, or even if you are using linear separable lines also, if you plot it, then also it is possible to verify that. You don't have to worry, but this is the simplest way. Simplest way is find out y in, apply activation function and calculate what is the threshold value, and you test the network. Okay, this is how we design Adeline network and how we get the model. Okay, my next class will be, I'll be discussing the multiple. Okay, we can call it as a Madeline network. Okay, we will design similar to this. Some calculations are involved. You have to do that along with me. You have to do some calculations, then only you can understand. Even if you are using MATLAB, I mean, MATLAB can be used. It is very simple neural networks implementation purpose. But this is the theory which you must know. Okay. Yeah, this is. I'll close today's class. So next Madeline network. In my next class we will discuss. Okay. Before we close, I'll take attendance. Just wait for 1 minute. Okay, so any doubts, you can just put a message in Teams. Okay, any doubts if you have. Okay, that's all for today. Thank you.
Thank you, ma'am.
Yeah.